Lesson 5 of Unit 6, our second last lesson. In this lesson here, we're going to learn about another type of equation. And this type of equation is called slope-point form. The one we learned about in 6.3 was called slope-intercept form. Okay, so we have already learned about the explicit form, or as I call it, the slope-intercept form, and that's that y equals mx plus b. Okay, now we're going to learn about another form called slope-point form. And the reason it's called slope-point form is because it gives you the slope and a point. That's why it's called slope-point form. Okay, so the slope-point form of an equation, this is what it looks like. This is kind of the general form without numbers plugged in. So y minus y1, the little 1 there, equals m, and then x minus x1 in brackets. Now, when you actually see the equation of this form with numbers plugged in and everything, there's going to be numbers in those 3 spots. Those will actually have numbers in them, okay? So the number at m will represent the slope, just like in the slope-intercept form. M is the slope. That number there is the slope. Then here's the weird thing. This is what's new. What I do is I take the number that's right there with the x, I take the number that's right there beside the y, and I put them together in a pair of brackets. And there I just formed a coordinate point. I just formed a point that will be on the graph. So I pluck out the x value, I pluck out the y value, I put them together, and that will represent a point on the line. Okay, but a little special note here, when you pull out these 2 values and put them in a point together, you have to switch the symbols. So if it was a positive while it was in the equation, when you pull it out, it will be a negative. Okay, that sounds like a lot. It's not complicated at all. And I'll show you with the next example, okay? Just going to erase some of this stuff. Okay, so example number 1 says, from each equation, determine what the slope would be and determine the coordinates of a point. Determine what a point would be on this line. So here's the equation in slope-point form. That's what it looks like. Like I said, there's actually numbers plugged into these 3 slots now. Okay, so the slope, easily enough, is just the number that shows up in front of the bracket. That's our m spot. Okay, now if I asked you for a point that would be on that line, if we were to draw this, this is what we do. We first take the value that's with the x, that's the 4, and we're going to put it in the bracket out front, but like I said, we switch the symbol, so it's now a -4. That's our x value in our point. Then we take the value that is shacked up with y there, the 2, and that will be the y value of a point, but again, we switch the symbol. So there you go. We know 2 very important pieces of information to draw this line. Okay, let's do another one. So if I gave you this equation here and I said, tell me what the slope is, super easy. The slope is that fraction there in front of the bracket, 3/5. Then if I asked you to give me a point, what would a point on this line be? First of all, you take the x value, which is that +2, but flip the symbol to a -2. Then for your y value, you take that 1 that's beside the y, we flip the symbol, it would be a +1. Pretty darn simple, actually, right? Okay, this one here, I put this in here for a reason, because it has a little bit of a head scratcher element to it. What's my slope? I'm sorry? There's no slope? Every line has a slope. 0 slope? Oh, that's complicated. Okay, what Savannah wants to do is to plot the points and then do the hopping, but we only have 1 point. You need 2 points to do hopping. Isaac, you think it's 1? Isaac's right. What's a number in math that always is there, but we really never have to actually write it? A 1. So it's like that there's a 1 out there and with the brackets, but whoever created this equation was like, oh, you know what? We don't need to write that 1. And if we remove the 1, we might as well remove the brackets too. Okay, so in this case, the slope is 1. Sam, if the slope was 0, it would be like that. And the whole right side would just be 0 then. There'd be no right side at all. That's the difference. Okay, so then if I ask you for a point, the x value is that 3, so I switch it to a -3, and the y value is that -7. I switch it to a +7. And the last one. Okay, the slope is just -2, just the number in front of the bracket. It's that easy. And then if I ask you for the point, the x value is -4, so I write 4. The y value is +2, so I write -2. So that's how you pull out the information. It's very simple. Now what I want you to do is I want you to graph the equations of A and D. So if I'm asking you to graph equation A or from A, that's this guy right here. And we've already pulled out the important info. So I know I have a point at -4, -2. So the first thing I'm going to do is go on my graph and draw a point at -4, -2, because I know for certain that's a point on the line. Then to find the next point, another point, all I do is I do my rise over run, which I was told is -2 on 3. So my rise over run is -2 on 3, so that means I go down 2 and to the right 3. Of course, your other option is flipping that negative to the bottom, which would mean you go up 2 to the left 3. I don't care in what direction you go, as long as you give me 3 points minimum, okay? Join your points. We're looking for a line, not just dots. Connect the dots. Put arrows on it to show that it goes on forever. Okay, now I want you to graph D. So the information from D told us that we have a point at 4, -2. So x is 4, y is -2. That's the point right there. I chose this one for a reason. What's my slope? Okay, so this is what a student's going to do. I guarantee it. I guarantee someone will do this. The slope is -2. They go down 2. Over 1, right? Every slope is actually a fraction. So it's -2 down and 1 to the right. Of course, you can always flip that negative to the 1, which would mean you would go up 2 and to the left 1. Join your 3 dots, put arrows on the ends, and there's the line of that equation. Questions? Sylvana, you look confused.
Yeah, I think I don't know. I can see that fast on D.
You what?
You go fast, and then I didn't kind of.
You want me to explain this again?
Yeah.
D?
Just D, yeah.
Okay, so I look at my starting point, or the point that was given from the equation was 4, -2. So I know I can start by drawing a point there. It'll for sure be on the line. Then to find the other points, I take the slope that the equation gave me, which was -2. But we know that slopes are always actually fractions, so I threw it over a 1. So my slope is -2 over 1. So I went down 2 and to the right 1, and that's how I found my other point. You're good? Okay. All right. This next question is just the opposite. I give you the information, you make the equation. Super simple, okay? So write the equation in slope point form of a slope that is -2 over 5 and it passes through that point, -4, 6. Okay, so it's y, starts off the equation always. And then beside y is the y value from the point. So what am I going to write? -6, right? So if it was a +6 in the point, that means it must have been negative in the bracket, right? Because we always switch the symbol when we brought it out. Equals, and then the slope is -2/5. Open up your bracket, and then you have the letter x with the x value, which is -4, so that means it was a +4 in the equation. Can we handle that? We'll do one more because some of you gave me a little look of fear. Okay, so slope of 15 that passes through that point. So again, the equation always starts off with a y. Then beside the y will be the y value from the point, which here is -3, but we remember to flip the symbol to a +3. Equals, then my slope is just 15. Open up that bracket, then you have the letter x with the x value, which if it was +2 in the bracket, it becomes -2 in the equation. That's how you work backwards. Okay, all right. Last question. The first one's easy. Whenever I give you the graph, is generally easier because everything's plotted out for us nicely. Okay, so the first one's going to be easy. That second one is going to be a bit trickier. So that's the one we're going to star or highlight or make a note of because that's going to be on your test. Okay, but first of all, we'll just do the graph here. It says for each graph to determine the slope point form. Okay, so we're going to determine the equation of this form, first of all. And then B says determine the explicit form, or explicit form, I mean slope-intercept form. So that's the one we learned from 6.3. So now we're going to create both types of equations for the one line. Okay, so for both of these scenarios, for both of these equations, I need to know the slope. Each one of them has an m in it, right? I need the slope. So like I said, life is easy when it's graphed for us because I just go down 1, 2, 3, 4, 5, 6, 7, 8. Down 8 means -8. And 1, 2, 3, 4, 5, 6, 7, 8 to the right means +8. So I know my slope is -8/8, which reduces to -1. So I found my slope. I'm halfway there. So if I start with A, and A is to create the slope point form, hence the title, slope point. I need the slope and I need a point. Do I have a point? Yes, I was given 2 points. So you have options. You can choose whichever point you want to plug into the equation, okay? All right, so I'm doing A here. A is slope point form, which means I start with Y. And then for the purpose of this question, I'm going to use this point up there, okay? So then my y value is a 3 in the point, so it will be a -3 in the equation. My slope we found to be -1. And then I put the x down, and then the x value from that point I chose was -2, so I write +2. Sorry, I just took the information from the graph and plugged it in. Now, the next one it wants me to write is slope-intercept form, hence the title. I need the slope and the intercept, the y-intercept, okay? The y-intercept is just where it crosses the y-axis at. It crosses the y-axis at a +1. So that equation is very easy. It's y equals mx plus b. M, our slope, is -1 with an x tacked onto it. And then my intercept, where it crosses the y-axis, is +1. So there you go. That's 2 ways to write the same, or to represent the same graph. Both those equations mean the same thing. Okay, that's kind of the easy one because we had everything drawn out for us. Now we're going to get to this guy, okay? So for this one, it's trickier because I don't draw it out for you. I just give you the 2 points. So again, to create those 2 equations, I need the slope. That's unavoidable. I need to know what m is. And lucky for us, we learned a formula the other day that helps us find the slope when we just know 2 points. Remember that? Ring a bell? I hope so. So if I plug this in, My y2, or the y value for my second point, is 3. So it will be 3 minus 4 divided by x for my second point is 6, subtract x for my first point is negative 2. So when you simplify that, 3 minus 4 is negative 1 on the top, and 6 plus 2 on the bottom is 8. Okay, so for slope point form, I need a slope, which I have, and I need a point, which I have. I was given 2 points. So again, just choose one. I'll choose the second one this time, but it doesn't matter. You choose any point you want. So my equation would look like y, and then the y value is 3, so I write minus 3. Then my slope is negative 1 over 8, open the bracket, x, and then my x value was positive 6, so I write negative 6. And they were already done the first one. Okay, this is where it gets because for the second equation, my slope-intercept form, I need the slope and the intercept, or where it crosses the y-axis, right? Do I have a nice, pretty picture to tell me where it crosses the y-axis? No, I don't. That's why this one's tricky. Now, let's do a little review of something from Unit 5. You don't have to draw this. When we have a graph, and you have a line, that's the y-intercept, right? Where it crosses the y-axis. What do we know about x at that point? I'm sorry? Oh, the x-intercept would be negative. No, I'm talking about this point right here that I just drew. What do we know about the x value at that point? It's 0, right? Because it's right over top. That is 0 on the x-axis. So we know for certain that the y-intercept always crosses where x is 0. Make sense so far? Okay, so if I want to find the y-intercept, all I do is take the equation I just found and replace or force x to be 0. Okay, you guys did this in Unit 5. Unit 5, Lesson 8, I gave you an entire assignment where I said, find the y-intercept by replacing x with 0. Once you replace x with 0, we can whittle this equation down, and eventually we'll just get y equals something. And that number is that right there. And therefore, we would know where it crosses the y-axis at. So I'm forcing x to be 0. I'm forcing myself to find that point where x is 0, aka the y-intercept, okay? So that's what I'm going to do. I'm going to take this equation we just found, and I'm going to replace x with 0. I would write this down, you guys, because this is on the test. Okay, so now I'm working on B. So I take my equation, and wherever I see an x, I am forcing it to be 0 so that I can find what y is when x is 0. So it looks like that. Okay, so now I just clean this up. So my left-hand side is y minus 3. I can't really do anything with that. But on the right-hand side, the bracket, well, if it's 0 minus 6, I know that that bracket just becomes negative 6. 0 minus 6. Okay, now I can multiply those two together. Let's clean those up. Now, just a little reminder, you guys, when you're multiplying, we have to remember that this negative 6 is actually over a 1. So when you multiply, you start by multiplying just the top guys together, which would be positive 6, right? Negative 1 times negative 6. And then you multiply the bottom guys together, which would be 8. Now, our goal is to isolate y, right? I want to know what does y equal. So I'm going to add 3 there to make that go away.
Please excuse this interruption. Can we please get Mariska Crumley Jonah Koontz, Evangeline Kell, Adam Cater, Cyrus Biancolet, Aiden Campbell to the office.
So now if I add 3 to both sides, my right-hand side becomes 0.75. I change that to a decimal. That's okay. When we're graphing, decimals are preferred. So I change 6.8 to a decimal, add that to 3, and there we go, you guys. I just found out that when I make x 0, y ends up being 3.75. In other words, this is the y-intercept. That's where it crosses the y-axis at, because we forced x to be 0. And we know that's going to make it cross the y-axis there. So the y-axis, there's the intercept's 3.75. So now the actual question was write it in slope-intercept form. So slope-intercept form of the equation is y equals mx plus b. M being the slope. We already found the slope to be -1/8. And then on the end, is where we have the y-intercept. Yeah, that's as hard as it really gets, okay?
That's the only thing I'll remember on the test.
That's what?
This is the only thing I'll remember on the test.
Yeah. Okay. So this is on the test, a question like this, okay? So make sure you took really good notes. And the assignment's written at the bottom, but the bell's gonna ring right away so you can pack up or get organized to get going for lunch.